Alright, this is assignment 4 for graphics. So for question 1, if I run this here, this is the optimized shader with the appropriate shader class. So you'll see here I only have a single buffer and data struct with single matrix and the color. So that's changed. And now this is my shader class where I have a send world view projection color, where I create the data struct and pass in the appropriate values, and then I update my sub-resource, which again is just the single matrix and color. And then I set the context, so if I go to my DX app, I send the world's view and projection and a color, render it, and then I get this. For question 2 is the further optimized rendering, so here's my 5 objects. And now what I did for this one is I offloaded the view times projection multiplication to be called once per draw instead of once per object in the draw. So it's a bit more performant in that regard. So now the send world view projection color really only just takes world now and a color, and then I render the object. So if I go here, in my header file, I calculate VP, which is matrix data member, as view times projection once per draw cycle like I showed. And then for send WVP, now I just multiply world times VP, which is pre-calculated, and then update the sub-resource appropriately, and that works just fine. Question 3 is the pyramid. So I mapped all the UVs correctly to match your image and the texture. And if I show the bottom, that's all good too. And the way I did this is literally just matching the vertices with their appropriate UVs. And you saw that came out to be correct. So there you go. For question 4, this was the box texture that wasn't repeating. So I created a new model called 6-face texture, which is the same verts and tries, but now I pass in the correct UVs for each vertex. And since each triangle can't share vertices because they need to have their own UV mapping, then I had to create all of these. But there you go. And these are the UVs that I passed in, which I matched to the image. And you'll see that this is correct. We're looking at the back of the cube. Because the camera is behind the cube, positive Z is into the screen. And then we have forward, right, left, top, and bottom. So there you go. Question 5 was my shader texture class. So I'll run this here. It's the exact same thing with the textured cube you just saw on question 4. But now this is different because it's using my shader texture class. So I create a new model with a 6-face texture model, a new texture, which is cube faces, and then my texture shader, which is called shader texture, with the device. And then if I go here to shader texture.cpp, I set the layout on the constructor with position and texture coordinates, do all the appropriate buffer creation. Here's my destructor for my 2 handles. Set to context is pretty straightforward when I pass in the appropriate buffers and their registers for the data. Set texture resource sampler just takes the texture and sets it to context. Send cam matrices, of course, takes the view and projection, sends those to the buffer, and then the shader on the GPU multiplies those as well as the world matrix. Of course, this could have been optimized just like my other 2 examples, where the GPU doesn't do as much of the multiplication, but just for the purpose of the question, all I did was create the shader for the texture, and there you go. And then, of course, I could change this to, I believe, test 512 was one. I can't remember off the top of my head right now. I think this was one of them. Go here. And obviously it's not going to match correctly because this is the 6-face texture rather than repeating, but there you go. I can change the texture and my shader works just fine. For the further work question 1, that was the texturing cube. So that uses the test 512, but you'll see that it's all red, and the reason for that being is that the model I'm using isn't UV mapped correctly. So all of the UVs by default are set to 0, 0. So that means that it's using the top left corner of whatever texture I pass in. And given that the test 512 texture has a red pixel at the top left, it's using that, and so it's coloring the whole thing red. If I were to properly UV map it like I did with the 6-face cube, then I wouldn't have this problem. But because it's defaulting to 0, 0, the whole thing's red. For question 2 of further work, I did some optimization of my own on my texturing cube and creating a whole bunch on screen and rendering them appropriately, and I saw pretty much no difference in performance. I relatively get the same amount of frames, which is anywhere from like 9,000 to 10,000 with a couple of dips. And this was even after multiplying the world times projection, world times U projection on the CPU, pre-calculating the view times projection once per draw cycle, and then testing that with the data analysis tool, and I pretty much got no difference. The only thing that really mattered is how many models I was sending to be drawn, because each model needs to do multiplication, and of course that's costly. So for me, the only thing that really mattered was the amount of models, because that meant more multiplications. But yeah, that's what I discovered for my optimization. But that's all I have, so thank you.